Okay, so here's a short video talking about cladograms, which comes from chapter 19, section 2. You should have already watched Mr. Anderson's video about this. So this is just an exercise I want us to work through together. And I sent you this sheet, which you need to print out so that you can work along with me. All right, so the way this works is we've got a group of organisms that we're going to consider their relationship. So remember, with a cladogram, not only are we trying to organize the diversity of life, we're also trying to show the relationships between different species in life. So we've got 7 groups of organisms, and we want to see how they're related. And the way we're going to figure that out is by our answers to some questions about features, whether they share these features, have these features in common, or whether they lack these features. So I'm going to use the tool as we look at each of these groups and think about which of these organisms have these features and which of these don't. And then that will allow us to construct our cladogram from that information. All right, so the first characteristic we're considering is, are these animals vertebrates? And the answer to all of these, actually, you might not be surprised, is yes. So you would put a check or an X in the box for all of those. All 7 get a check. So that's not helpful to us, really. It unifies all of them, but it doesn't show us how they're related and who evolved first. Some of these other characteristics maybe will be more useful. All right, so next let's think about, do they have a bony skeleton? Is their skeleton made out of bone? Well, you may know that for the sharks and their relatives, no, it's not. It's made out of cartilage. The ray fin fish, that would be a typical fish that you would catch. The amphibians, crocs, dinosaurs and birds, primates and rodents, yes, their skeletons are all made of bone. We have evidence of that. That's easy to see. Okay, so one group has left us, but the others all share that characteristic. All right, next, do these organisms have 4 limbs? We can call a 4-limbed creature a tetrapod. Well, sharks and their relatives, no, they do not. They have fins, but they don't have limbs. Neither do the ray fin fish. But amphibians, crocs, dinos and birds, primates and rodents, yes, they all do. All right, our next characteristic we want to think about is amniotic egg. Now, that's an advancement where the developing embryo is protected inside membranes, one of which is called the amnion. And then that amnion contains fluid around the embryo, and there may or may not be a shell around that amnion. The shell may be like a bird's egg shell, it may be leathery, or it could be enclosed inside the mother. Well, we've already left the sharks and the fish off. Here's where the amphibians leave us. If you've ever seen frog eggs, they're very squishy and they're unprotected, which is why they have to be in water, because they'll dry out. But the others, yes, they have amniotic eggs. Reptiles do too. The coverings on their eggs are leathery. We know bird eggs. With primates, which we saw yesterday, our amnion is a membrane layer inside the mother's womb. Okay? And rodents are the same because they're mammals like us. All right, our next feature, do these organisms have hair? Okay, now we're going to start leaving some friends behind, because we know crocodiles, dinosaurs, and birds don't have hair. The birds have feathers, but that doesn't count. So only the primates and the rodents would have that characteristic. And then eggs with shells. Well, we go back up here. These guys and these guys lay eggs with shells, but the rest of them do not. So now what we need to do is total up the number of checks across each row. As you can see, the sharks and their relatives, they only get 1. The ray fin fish get 2. The amphibians get 3, We've got 5, 5, 5, 5. Okay, so what shall we do with that information? Well, we'll organize this into a cladogram. So the dots here will represent features that are shared by organisms. And obviously the feature that's shared by all of them is being a vertebrate. So I'm going to put V here because I can't write it out, but you could write the word vertebrate. So that's going to show that everybody on this cladogram is going to share that feature of being a vertebrate. Obviously there are other cladograms of other organisms you could construct, but of the ones we're looking at, that's the shared characteristic. All right? Who's the first group that branches off next and will not share any other characteristics? Well, that would be the sharks and their relatives. Here, they share none of these other characteristics, so they would be the first to branch away from the other groups. The next shared characteristic for everybody else would be here, the bony skeleton. So I'm just going to write a B for bony skeleton. All right. The next group that leaves us after that would be the ray-finned fish. I'm just going to put fish. Okay. The next characteristic that's going to be shared by the remaining organisms would be having 4 limbs. I'll just put a 4 here. All right. And so that excludes the fish and the sharks, but it includes everybody else. But the ones who are going to branch off from us after that would be the amphibians. Okay. All right, our next question that included the most would be having an amniotic egg. So I'm going to put an A here for amniotic egg. And this is where things will start to get a little bit confusing perhaps because we had a tally of 5 for everybody else. All right, so let's think about this. The next ones who have a shared characteristic between them that nobody else shared was having eggs with shells. Nobody else had that. So that's what needs to go here. I'm going to put ES for eggs with shells. That characteristic then links the crocodiles and the dinosaurs and birds. So crocs and DB. Can't fit it. Right. So that's a characteristic that none of the other groups share. It obviously evolved after their relationship here. And then the last characteristic, obviously you can see, is having hair. And that's where the rodents and the mammals branch off here. All right, so what is this telling us? Everywhere there's a branch point, so that would be here. Everywhere there's a branch point, that's telling us that these organisms had a shared common ancestor. Both of these animals belong to mammals, so they share common ancestry as mammals. That's why they have certain characteristics in common. Now, obviously on the tree of life, they branched off and went their separate ways. And then they have a lot of characteristics not in common. You could expand upon the cladogram and work on that too, but this is complex enough. All right, so back here, there's a shared common ancestor for the lines that would lead to the reptiles, as well as the lines that would lead to the mammals. There's actually been some fossil studies recently that have shown that possible ancestral form for that. There's a whole book about it called Your Inner Fish. It's pretty interesting. All right, the amphibians share a common reptile with all of these here, and then they branch off and go their own way. The fish share a common ancestor here, and the sharks shared a common ancestor way back here. You can think about this as a timeline if you want to. These guys diverged or broke away from the rest of these organisms in the animal kingdom in phylum Chordata before these did, who branched off before these did, who branched off before these did, and so on. So they share a more recent common ancestor than they do with these. So they are more closely related, evolutionarily speaking, than they are to these. They are more evolutionarily closely related than they are to the amphibians, and so on. And that's how a cladogram works. So you're going to answer a few questions about this, and this information will be on your quiz tomorrow. And like Mr. Anderson, I hope that helps.